विद्यार्थी मित्रांनो, ह्या लेक्चरमध्ये आपण घेणार आहोत कॉचीज इंटिग्रल फॉर्म्युला. If f of z is analytic inside and a closed contour C of a simple connected region R, and if A is a point inside C, then f of A is equal to 1 upon 2 pi I integration over C f of z upon z minus A dz. We have to prove this, and this is known as Cauchy integral formula for f of A. Okay, what is given that f of z is a analytic inside and on the closed contour C, and A is a any point inside the closed contour C. This is a closed contour C. This is the R region. R f of z is a analytic inside the region, and this is a closed contour C where f of z is analytic inside and on the boundary of C, and this is A lies inside the C. Now then f of z upon z minus A is analytic inside on the closed contour C except at point z is equal to A. So f of z is upon z minus A is a function which is analytic inside the C except at the point z is equal to A. Draw the circle C1 with center at z is equal to A and radius is delta such that it lies completely inside T. असा एक सर्कल ड्रॉ करा ज्याचं सेंटर A आहे आणि ज्याची रेडियस डेल्टा आहे अराउंड A with such that the circle lies inside the C. Totally lies inside the C. Therefore, now f of z upon z minus a is analytic in the region between C and C1. Now, this is a integration. This is a सर्कल सी इस बाउंड्री आणि सी ची बाउंड्री या दोघांच्या मध्ये एफ ऑफ झेड इज एनालिटिक आहे. ऑल्सो इट इज ऑन द एनालिटिक ऑन द बाउंड्री ऑफ C1 and boundary of C. So by using corollary of Cauchy's theorem, we get integration f of z upon z minus a dz over C is same as integration f of z upon z minus a dz over C1. So this is equal to integration C1 f of z minus f of a plus f of a. Here add f of a and subtract f of a upon z minus a dz. Okay, or this can be written as integration over C f of z upon z minus a dz is equal to integration over C1 f of z minus f of a upon z minus a dz into f of a into integration over C1 z dz upon z minus a. Now consider this integration over C1 z upon dz upon z minus a. We have to calculate this. So for any point z on C1, z minus a is equal to a plus e raised to I theta, because z is equal to a plus r delta e raised to I theta, because it's a circle with center at a and radius is delta. So every point of that inside and on the circle can be written as a plus delta e raised to I theta, where theta varies from 0 to 2 pi. So dz becomes, take the derivative of this, a is constant, as a derivative 0 will delta e raised to I theta derivative, delta is a constant, e raised to I theta e raised to I theta into I. So it is I delta e raised to I theta d theta. This over dz. So this integral becomes integration over C1 dz upon z minus a dz equal to integration over 0 to 2 pi. Value of dz is I delta e raised to I theta d theta upon delta e raised to I theta. So delta e raised to I theta, delta e raised to I theta gets cancelled. It becomes I into e raised to I into integration from varies from 0 to 2 pi d theta. D theta is the integration theta's limit varies from 0 to 2 pi. So I into 2 pi minus 0, that is 2 pi I. This is the integration of this is nothing but 2 pi I. Now substituting this equation in equation 1, we get integration over C dz upon z minus a integration over C dz upon z minus a is equal to integration over C1 f of z minus f of z f of a upon z minus a dz plus f of a into 2 pi I. This putting this a value of this integral. Now this gives 1 upon 2 pi I dz upon z minus a dz is equal to 1 upon 2 pi I integration over C1 f of z minus f of a upon z minus a into dz plus f of a. Now we have to calculate this integral 1 upon 2 pi I integration over C1 f of z minus f of a upon z minus a dz is equal to 0. We have to show this is 0. Then we get the desired result. So consider the modulus of this is nothing but it is less than equal to 1 upon 2 pi I integration over c1 modulus of f of z minus f of a upon modulus of z minus a into modulus of dz. So modulus of 1 plus I is nothing but 1. So 1 upon 2 pi I integration over c1 modulus of f of z minus f of z f of a upon delta. The modulus of z minus a is less than equal to delta because the radius of this circle with center at a and radius is delta, so it is less than equal to delta into integration of delta z. Since f of z is analytic inside and on the closed control C, it is continuous inside and on the closed control C. It is particularly continuous at z is equal to 0. So for every epsilon greater than 0, there exists delta 1 greater than 0 such that modulus of f of z minus f of a less than epsilon whenever modulus of z minus a less than delta 1. Choosing delta such that delta less than delta 1, so modulus of f of z minus f of a less than delta whenever modulus of z minus a less than delta. Hence this above becomes this modulus of this integral strictly less than 1 upon 2 pi. Put the value of modulus of f of z minus f of a is less than delta, so it is less than epsilon, and modulus of this is like delta and integration dz. Epsilon upon delta is a constant, take it outside, so epsilon upon 2 pi delta integration over c1 dz, and integration over say, c1 dz is a circumference of circle c1 which is equal to 2 pi delta circumference of circle c1. आणि आपल्याला माहिती आहे सर्कम्फरन्सचा फॉर्म्युला काय 2 पाय डेल्टा 2 पाय आर. आर इज नथिंग बट रेडियस, and रेडियस इथं रेडियस काय डेल्टा, so it is a circumference is nothing but 2 pi delta. So this is strictly less than epsilon upon 2 pi delta, and this integral is nothing but 2 pi delta. So 2 pi delta gets cancelled, so we get this is less than epsilon, and epsilon is arbitrarily very small, which is less than any positive number, therefore it must be 0. This modulus must be 0, so this integral must be 0, and hence we get the desired quasi integral formula for f of a is equal to 1 upon 2 pi I integration over c f of z upon z minus a dz. Similarly, we can calculate the Cauchy integral formula for f dash a is nothing but f dash a is equal to 1 upon 2 pi integration over c f of z upon z minus a bracket square dz, and we can extend this Cauchy integral formula for nth derivative also. So nth Cauchy integral formula f n a is nothing but it is given by fn a, there is a nth derivative of f of z over if z is equal to a, that is fn a is equal to n factorial upon 2 pi I integration over c f of z upon z minus a raised to n plus 1 dz. Now, using the Cauchy integral formula, evaluate this integration over c1 e raised to z upon z minus 2 dz over c1 is equal to circle modulus of z minus 2 is equal to 1, and this is second example integration over c2 3z minus 1 upon z square minus 2z plus minus 3 dz over c2 is a modulus of z is equal to 4. Now first f of z is equal to e raised to z, it is analytic everywhere in a complex plane. OHCM. Also, it is analytic on inside and on the closed contour C1. C1 is nothing but also is a center at 2 and radius is 1. Center at 2 and radius is 1. So here if you put z is equal to 2, then it is lying inside the this circle. So by Cauchy integral formula, जर एखादा point lies inside a cell, z is equal to the, then the integration over c1 e raised to z minus 2 dz is nothing but integration f of z upon z minus 2 dz is a 2 pi I into f of 2. F of 2 is nothing but f of z is a z e raised to z. Just put z is equal to 2, that is e square. 2 pi I e square. So this integral is nothing but 2 pi I e square. Resolving. Now here we have to find out the first the फॅक्टर्स ऑफ दिस इज नथिंग बट z प्लस 1 z मायनस 3, आणि याचे पार्शियल फ्रॅक्शन नुसार याला सेपरेट करा. दिस इज इंटिग्रेशन ओव्हर c1 1 अपॉन z प्लस 1 dz into 2 इंटिग्रेशन ओव्हर C2 1 upon z minus 3 dz आणि इंटिग्रेशन इथं सर्कल दिल्या मॉड्युलस ऑफ z is equal to 1, that is a center at 0 and radius is 4, so z is equal to minus 1 is also inside the circle and z is equal to 3 is also inside the circle. So by using Cauchy's theorem, this integral becomes 1 integration over C2 1 upon z plus 1 dz is nothing but g of z. G of z is nothing but is our 1. G of z is 1, so 1 upon 2 pi I. G of minus 1 is nothing but 1, so 2 pi I is nothing but it's a also integration over z C2 1 upon z plus 1 dz is 2 pi I. Again, if h of z is 1, so integration this is nothing but integral is nothing but 2 pi I into 1, that is again this is nothing but 1, so total integral is nothing but 2 pi I into 2 into 2 pi I, that is 2 pi I into 4 pi I, this is 6 pi I. Using this Cauchy integral formula we can solve this integral. These are the simple similar examples student can try at home by using Cauchy integral formula. This is the end of chapter number 3. Thank you.